Welcome to Take 5 with Automation World. I'm David Greenfield, Director of Content, and today we're going to look at the controller options facing OEMs and end-user automation equipment buyers. Now, it's been a little more than 50 years now since the invention of the programmable logic controller, or PLC. And though PLCs are essentially very basic computers used to control machine functions, they allow engineers to develop, modify, and expand the functionality of control systems through software rather than hardware changes to the system that were required in the past with electromechanical relays. Now, this capability really set the stage for the future of automation and control and many of the advances we're seeing today. But just as no technology is static, neither is the PLC. Over the years, suppliers added new capabilities to basic PLCs to address various end-user needs. And some of these new functionalities included things like integrated servo and drive control, network communications, advanced process control, and the ability to handle multiple programming languages. Now, with all these new capabilities, the PLC became more than just a basic controller. And that's how the term Programmable Automation Controller, or PAC for PAC, came into being. Basically this term better reflects the expanded and still expanding capabilities of controllers. Now, though controller suppliers use the term PAC to distinguish these more advanced controllers from their more basic PLCs, the boundaries between the two have become somewhat blurred. After all, with all the software and chip advances that have occurred over the past few decades, unless you're looking at the simplest controller to handle the most basic control functions, you're likely looking at a PAC. And both PLCs and PACs serve the same general purpose, but PLCs are typically specified for very basic discrete control operations, while PACs tend to be preferred when complex equipment features or automation infrastructures are required. Now, explaining all of this a bit further, Nate Kay with System Integrator Martin CSI says, most classic PLCs use a memory-based form of programming where the addresses are tightly coupled to a physical memory structure. But PACs let you focus on writing in the programming language you prefer while they handle the memory management issues in the background. PACs also allow tag-based programming, which increases the flexibility and scalability of the controller by allowing the tags to be assigned to functions before they're tied to specific I/O or memory addresses. And that's why PACs are often used for controlling larger processes and integrating things like safety, motion, distributed I/O, and network communications. Now, using a PLC for these kinds of applications would generally require adding hardware modules to perform those types of tasks. Now, the third controller option facing buyers is the industrial PC, or IPC. And Frank Berger with System Integrator Avancion says these software-based controllers feature similar programming environments and firmware as a PAC, but they're hosted on a regular computer platform. And the advantage here is that IPCs can run multiple applications, not just the control programs. For example, you can run databases, protocol converters, and recipe managers on an IPC, as well as your SCADA and MES software. But like any PC, IPCs can require more frequent updates and patches and may not be able to operate effectively for as long as a traditional PLC. IPC suppliers, however, maintain that PC-based control can be just as effective and dependable as PLCs and PACs in demanding applications such as high-speed motion control. And they point to their many decades of wide use across industry as evidence of this. Now, beyond machine control, IPCs are also used in cases where there may not be an existing server or network infrastructure in place at that area of the plant floor. And since they have the full features of a PC, the IPCs can be used for these kinds of applications. They're also used where processing power is needed at a specific location, such as with machine vision applications. Now, because each control system option is unique, Many industry experts advise consulting with a trusted system integrator before making a choice. Andrew Abramson with System Integrator Grantech says, an integrator can help you weigh the cost and benefits of the different architectures, including things like initial capital investment and ongoing maintenance costs, as well as the risks and functionality inherent to each of these different types of controller options. So I hope you found this Take 5 with Automation World helpful.